In this video, we'll now look at more limit examples based on trigonometric properties. So for this one here, as we're looking at it, you'll note that it's 1 minus cosine squared of x all over x. Now I also want to make a point to emphasize that the rule or the property that we'll probably end up using is this one here. And the reason, this one here. And the reason why we'll probably end up using this one here is because we've got 1 minus cosine of x, and it's divided by x. Now this, you'll note, is not the exact same thing as this. Now if the interiors were the same, and this was a single power of cosine, then yes, this whole limit would be equal to 0. But because that because that cosine is squared, this entire function doesn't equal to this entire function, and therefore we can't make a direct substitution of this whole limit equaling to 0. With that being said, we're going to have to consider possible other options of evaluating this limit. Well, we do have direct substitution we could attempt. We can't plug those in. We could consider a conjugate method, but the conjugate method generally only works when we're talking about radicals. Now, can it work in this case? Not this one, but it can work in other trigonometric functions depending on the situation. What I'm seeing for this one, however, is that we can simply go ahead and attempt to factor this function. So I'm going to have the limit as x goes to 0 of the top thing here. I will note that this is the same thing as 1 minus cosine x and 1 plus cosine x. So this is technically viewing this as a conjugate. You'll notice here that 1 minus cosine times 1 plus cosine are actually conjugates of each other because of the minus sign here and the plus sign here. So with this, I can now rearrange this so that this is the limit as x goes to 0 of 1 minus the cosine of x divided by x times the limit as x goes to 0 of 1 plus cosine of x. And again, the only way that I'm actually allowed to do this is if this limit exists, and it does, and it goes to 0, and if this limit exists. And if this limit exists, then I'm multiplying 0 times whatever this is. It's important that we can't just assume that this limit is not going to be important. If this limit goes to 0 and this limit doesn't exist, then I can't separate this limit over those two functions. It is extremely important that you actually evaluate this limit. So when I plug in 0, I get multiplied times 1 plus the cosine of 0, remembering that the cosine of 0 is 1. So this is 0 times 2, which is then 0. And this overall limit exists because each separate piece of the limit actually exists. This is not the only way to evaluate this limit. There is another way that you could evaluate this limit using the Pythagorean identity, such that you replace 1 minus cosine squared with sine squared. Now again, this isn't a perfect application of it because the limit rule that we have is the limit as x goes to 0 of sine of x over x equals to 1. But in this case, what I'm going to have to do is I'm going to have to manipulate this function so that it's the sine of x over x, and I have some stuff left over. So manipulating this will provide me with the sine of x times the sine of x all over x. I can group two of those pieces together, okay, multiplied by the sine of x, such that this ends up being limit as x goes to 0, sine of x over x is 1 times the sine of 0. But if we recall, the sine of 0 is simply 0, and sure enough, we get 0 all over again. So you'll notice there that there are two different methods to evaluate the exact same limit. Let's look at the next example in terms of the limit as x goes to 0 of the sine of 2x divided by 5x. Now the problem with this one here is you'll note that there's a 2 inside the sine function, but a 5 on the outside. That 5 is actually going to mislead you. Keep in mind that we need the inside to be the exact same as the outside in the denominator. The problem, however, is the fact that we can't actually manipulate the inside unless we were going to use Pythagorean, double angle, half angle, power reducing identities. And I don't think we really want to use that identities unless we absolutely have to. There is an identity that would work here, but instead of using an identity, I'm simply going to go ahead and tear apart this function. First, I'm going to make it the sine of 2x times 1 over 5 times 1 over x. Now again, you might not actually need to write it out like this, but writing it out like this will help you see all the pieces. And by seeing all the pieces, you know that by grouping this one here with this one here will give you the sine of 2x over x. And all we'll need is a 2 in the denominator here. So let me go ahead and rewrite this so that I have the limit as x goes to 0 of the sine of 2x over x times 1/5. You'll also note that the constant here could then be pulled out of the actual limit because it's just a constant multiplied by everything, assuming this limit exists. We're going to have to do a little bit more work to make sure that this limit exists, but I think we're in the right track. You'll notice that this limit here is actually very similar to the first example we did, such that we had a 3 on the inside and nothing in the denominator. So to make this happen, I'll simply multiply on top and on bottom on the outside of this limit by 2 over 2. I need 2 because that way this 2 will match up with the 2 that's going to be down here. So this 2 here gets pulled inside. I'm going to take this 1/5, I'm going to pull it outside, giving me 2 over 5 times the limit as x goes to 0 of the sine of 2x divided by 2x, and because these two functions inside the sign and outside the sign in the denominator are exactly the same, the limit of the sine of something divided by something as x goes to 0 is going to be 2/5 times 1. And therefore this final limit is simply equal to 2/5.